All right, today's conic section is hyperbolas. And if you have your little packet from yesterday, this is like if you had two cones on top of each other and you took a knife and you went slice and you got two at the same time. Two pieces. So it's like a hyperbola is kind of like you have you have a parabola going up and a parabola going down. Or if you flipped it on its side, then you could have a parabola going left and a parabola going right. Okay? So if you look at your packet, you can see that hyperbolas have two different equations. The first equation has the x squared first. That means that the parabolas are going left and right. The second equation has the y squared first. That means the parabolas are going up and down. Okay? So hyperbola is just like double parabola. All right? Okay. So let's go ahead and start off with what a hyperbola is as it's defined. So we're going to say the collection of all points in a plane, because that's how they all start. So hyperbola is the collection of all points in a plane. I know someone's not listening to music right now because that would be rude.
It could just be the guy's voice from the other.
No, there's definitely music. Who's got their headphones in?
Yeah, it's coming from over there, but it's not him.
It's none of us. Y'all gotta keep looking at us. Y'all can turn around.
I can't, you guys, I don't have supersonic hearing. It's not from next door. It's definitely in this room. So check your headphones, see if you, okay. All right. The collection of all points in a plane such that the difference of the distance between any point to each focus is constant. The collection of all points in a plane such that the difference, what does difference mean? Subtract. Okay, such that the difference of the distance between any point to each focus is constant. So this time, instead of finding two distances and adding them together, like we did on an ellipse, we're going to take two distances and we're going to subtract them. Okay? So we're writing that down. We're going to draw a little sketch of a hyperbola. So the center of the hyperbola is right there. He can project his voice. He's really good at that. We have two vertices, but we don't have any co-vertices this time. So we've got a center, a vertex, a vertex. And then inside each parabola shape, we have a focus. So focus there, so we still have foci, or foci.
Hello, excuse me.
All right, listen up. So what this is saying is that if I choose a point on a curve, there's a point right there. You can't see it very well. And I find this distance right here, and I subtract that distance right there, that's going to give me a number. And then if I take this point right here, and I find this distance, and I find that distance, and I subtract them, it's going to give me the same number. That's what that definition is saying. So it's just saying whatever point I choose on the curve, if I find those two distances and subtract them, it's always going to give me the same number. Okay? All right, and again, if you don't understand that definition or if it seems abstract in your head, that's okay. You can still work with them even if you don't understand that definition. Okay? That's something that as we get deeper and deeper into mathematics, some of that stuff will start to make more sense and it will be beneficial for us to have known that. But for right now, that's a little bit outside of what this class works on. Okay, so I'm just letting you know what the definition is. If you don't get it, that's totally fine. Okay. All right, so we're going to go ahead and we're going to find all the different things that we can. Just like the past couple days, we're going to start off by looking at the equation and graphing it, and then after that, we're going to get some clues and we're going to figure out what the equation should have been. Okay, so we're going to write down the formula. We have it in our little cheat sheet packet, but we're going to write it here also. So we have x minus h squared over a squared minus y minus k squared over b squared equals 1. And this would be hyperbolas that open left and right. And we know that because the x comes first in the equation. And then we also have the formula y minus k squared over b squared minus x minus h squared over a squared equals 1. And this time, since the y came first, this one opens up and down. Okay. We're just taking notes, so we're quiet. All right. There's one more vocabulary word, well, two of them, that I forgot to put on the picture, so we're going to add to our picture here. There is an axis of symmetry right here that cuts the picture in half this way. And that axis right there is called the transverse axis. And then there's one that cuts through right here. And this is called the conjugate axis. Isn't it fun that everything has a different name?
No.
Hey.
Who was that who made that announcement about the ESL? Do you know who that lady is?
That was probably Phoebe in the office. Phoebe's like
What's
one of the
the-
secretaries. I don't know her last name. That's a problem.
So a number to the office, I guess.
Yeah, secretary may not. Oh, it's 56155.
56155. Got it. Thank you.
Yep. All right. So there's one more thing that we need a formula for, and that's once we draw these, there's actually an asymptote right here, and there's an asymptote right here. So the asymptotes cross each other at the center, and these little like parabola shapes follow the asymptotes forever. Okay? So we're going to write down the equation for the asymptotes. And there's always two of them because they cross, right? One with a positive slope, one with a negative slope. And the asymptotes, let me make sure I'm writing it correctly, is y minus k. So we're going to take that parenthesis right there, y minus k, equals b divided by a. And notice that's the number underneath y, or the square root of the number underneath y divided by the square root of the number underneath x. So you can think of this as like rise over run, times x minus h. And the way that we get two answers here is we put a plus minus in front of the slope. So you're going to find two asymptotes, one with a plus, one with a minus. All right, and you're going to write a little note to yourself always simplify to y equals mx plus b. So you can see that the formula that we're going to use does not give you the problem in y equals mx plus b, and you're going to have to simplify it to make it look like that. Yeah. Okay, so now we're going to go ahead and do an example problem. Okay, so we are going to graph x minus 2 squared over 16 minus y plus 3 squared over 4 equals 1. And once we find it, we're going to get all the things. So the one thing that like really makes these different from ellipses is a lot of people, when they look at this, they want to notice the 16 and the 4. And it doesn't matter what size they are this time. Okay, the thing that makes the hyperbola go different directions is whichever variable happens first. Okay, is it x squared minus y squared, or is it y squared minus x squared? So this one starts off with an x squared. What does that tell us? It goes left and right. Okay, so we're going to go ahead and start graphing this. We can write down what our center is, because that's going to help us figure out how to draw the axes. So what would the center be? Positive 2, negative 3. Okay, and we're going to end up going left and right 4 and up and down 2. So the way that you start graphing this is going to be exactly the same as the way that you graphed ellipses. We're just going to do something that's a little bit opposite, okay? So we're going to go right 2 and down 3. There's the center. And what we're going to do is we're going to go to the left 4 and to the right 4. And we're going to go up 2 and down 2. So if this problem had a plus sign in between, what we would be doing right now is we would be drawing that ellipse if it had a plus sign in between. Do you guys see how we started the problem exactly the same? Okay. Now this is not an ellipse problem. There's a minus in between, so this is a hyperbola. So the process for drawing these to make a hyperbola is you actually take these points and you draw them out like this, and we're going to draw a rectangle that goes through all those points. Yeah, this one is a little weird when you draw it. And then once you have the rectangle drawn, you draw your asymptotes, and the asymptotes go through the corners, the opposite corners, and they go through the center. So this asymptote is going to go like this, through the center of the box, and it continues on like this. My asymptote is almost straight. Okay, and then we'll draw the other one. So these are the asymptotes I was talking about that we're going to find an equation for. Like that. So if the y plus 3 squared over 4 had been first, then we would have been drawing the parabolas right here and right here. But since the x part is first, then we're going to take this and we're going to make it a parabola shape right here. And I'm making sure that I'm showing this as following those asymptotes, because that's how curves work. they follow the asymptotes. Yeah, it's weird, right? Now, technically, that rectangle is not part of the graph. So in theory, we should go back and erase the rectangle, but nobody does. They all just kind of leave it there. Okay? Yeah. The rectangle is important. It would hurt its feelings if we erase it. Yeah.
What did you do with the 16 and 4 again?
The 16 told me that from the center I should go left and right 4. The 4 told me that from the center I should go up and down 2. So I took the square root of 16 and got 4.
Oh.
Took the square root of 4 and got 2. Okay. So now that we have it drawn, we have some things that we want to be able to find about it. So we already have the center. When we can call this the direction, is that it's along the x. So that's just saying it opens left and right instead of up and down. We can find the vertices. So from the center, the vertices were left and right 4. So left 4 was -2, -3. Right 4 was 6, -3. I forgot another thing in your notes. I'm sorry, I'm so forgetful today. Underneath asymptotes, we're going to go ahead and write the formula to find the focus. So if you guys remember for ellipses, it was c squared equals b squared minus a squared, or a squared minus b squared, depending on the problem. For the focus this time, it is c squared equals a squared plus b squared. So it's the Pythagorean theorem. I don't think that it's related, but I haven't looked into that. So it is definitely related. It's the Pythagorean theorem. Yeah. I'll have to think about it later. Okay. So the focus, you find the focus by doing c squared equals a squared plus b squared. The way that I remember this is I remember the hyperbola has a minus in the middle, and so the focus has a plus in the middle. For ellipses, the formula has a plus in the middle, and so the focus has a minus in the middle. That's how I remember it, is that they're like opposites. Either way, it works out nicely because you have it in your packet, right? I said we could use these packets on our test. And if you look in your packet for hyperbolas, the formula is written there at the bottom for you. Okay? Yay! All right. Okay, so now we can go ahead and find the foci or the foci, however you want to say it. So we're going to add these together. 16 plus 4 is 20, so a squared plus b squared is c squared. 16 plus 4 is 20, so that means that c squared is 20. And so what is the c value? Square root of 20. And so that means the focus is always going to be inside of the parabola shape right here. So that means that the focus is going left and right from the center. And so we're going to write the center coordinate, the 2, and we're going to say plus square root 20 and 2 minus square root 20. All right, what is the transverse axis? Yep, negative. It's the y coordinate, so -3. Y equals -3 because it's horizontal. The conjugate axis is the one that cuts through right here. X equals 2. All right, and then we're going to go ahead and we're going to find the asymptotes. So first we take the parentheses that had the y in it, so we're going to say y plus 3. And then we're going to have plus or minus of b divided by a. So plus or minus, what's the b value? 2. What's the a value? 4. So it's 2 divided by 4. 2 divided by 4 is 1/2. And then it's the x parentheses, so x minus 2. Okay, are we allowed to leave the asymptotes looking like that? No. So what do we have to do? We have to simplify it. Now, because one of these is a positive 1/2 and one's a negative 1/2, we have to write this twice and show the work twice because the answers are different from each other. They're not going to be like one with the plus, one with the minus, and otherwise they're the same. They're going to be totally different from each other. So I'm going to write y plus 3 equals negative 1/2 times x minus 2. And y plus 3 equals positive 1/2 times x minus 2. So what happens on the first one when we distribute the negative 1/2? Negative 1/2 x plus 1 and then what do we do? Subtract the 3. So y equals negative 1/2 x minus 2. I don't know how it happened, but there's a monkey next door. All right, then what do we do? Same thing over here. So y plus 3 equals 1/2 x minus 1. Okay, what do we do with the 3? Minus it. Y equals 1/2 x minus 4. Okay, so there's our two asymptotes. Negative 1/2 x minus 2, positive 1/2 x minus 4. If you look over at your picture, then you can see that we do have a line that has a y-intercept of negative 2 and goes down 1, right 2, down 1, right 2. And you can see that the other one has a y-intercept of negative 4 and goes up 1 over 2, up 1 over 2. That make sense? Okay. So they do show up on your picture. In theory, if you don't like the rectangle option, you can find the asymptotes, graph them, graph your vertices, and then do it from there and not draw the rectangle. In theory, if you want it. Okay. All right, so first, what should we find? The center. The center is... Wait, be careful. It appears to be 2, 0, but be careful. It's 0 because the 0 goes with the x, and the 2 goes with the y. So be careful because it is written kind of backwards. 0, 2. Okay? So I'm going to go 0, 2, draw the dot. And then how far to the left and right should I go?
3.
Not 3. Be careful because that's under the y. 2, yeah. So you really got to watch these ones. Yeah, it's tricky. And then how far up and down should we go?
3.
3. 1, 2, 3. And now we draw our ellipse.
What?
No. Okay, what do we do? You're like, yeah, ellipses, we like those. All right, what do we do?
Draw the box.
Draw the rectangle, draw the box. Okay. And then we got to draw the asymptotes.
Do you have to go all the way out?
You have to go up forever.
Never stop.
The reason I draw the asymptotes so far out is so that when I actually draw my curve, I can follow it. If you draw your asymptotes and they stop like right there, then you're going to have a hard time drawing your curve. So I draw them extra far so I can follow it. Yeah.
It's width because the x and the, so whatever's under the x is going to be left.
Yes.
Not just the first.
Yes. So if we all want to make sure we caught that, we don't just say the first one tells us left and right, we say the one underneath x tells us left and right.
So
The one underneath.
For all of, like, everything
Yes,
we've done?
that's for everything that we've done. All right, so since the y value comes first, what does that tell us? Opens up and down. All right, so we're going to say direction. And how did I phrase this before? Along y. And so that means now. So we know the vertices. My box kind of wrote on top of them, but there's one vertex right there. The other vertex is down here. So what are the vertices? Yeah, so the vertices were up and down 3 from the center. Yeah. Because the y came first. All right, how do we find the foci?
Oh, it's c squared. It's a squared plus b squared.
So we have 9. Well, the a squared is really 4. So we've got 4 plus 9 equals 13. So c equals square root of 13. Okay. So from the center, we're going to go up square root of 13 and down square root of 13. So how do we write that? So 2, because it's from the center, right? So 2 plus square root 13, 0 comma 2 minus square root 13. And that was because we're using the y coordinate since we're going up and down. So on the example in our notes, we went left and right. This time we're going up and down. Okay, what else do we find? The transverse. Ooh, yeah, there you go. So the transverse axis is x equals something, right? It's a vertical line, so it's an x equals 0. The conjugate is y equals 2. Good. The transverse cuts through the parabola shapes. The conjugate goes in between them.
Can you just look at the equation?
The center, yes.
Like,
Or the equation, yes. Yeah. Yeah, because so we got the center from the equation, and those axes cut through the center, so they're going to use the same values. Yeah. Yes. It's the major and minor axis, but it has a different name since the picture is different. Yeah. Yep. And the it's not major and minor anymore because major is the longer one and minor is the shorter one. In this case, we're not saying longer or shorter. We're saying the one that goes through the parabolas and the one that's in between them. And so our rectangle could have been like short and fat, and they still would have been labeled the same way. Okay. All right, and then what else? We got one more thing. It's a pain in the butt. You got to simplify. Asymptotes. Get it? I said it's a pain in the butt, and they're asymptotes. You guys, come on. That was like legit a good one. You guys are so rude. I feel very beat down right now. All right. The asymptotes are, what do we write? y minus 2 equals plus or minus, it's b over a. It's not 9 over 4, that's b squared over a squared.
2 over 3.
It's 3 over 2. Do you see how easy it would be to mess that up? This is b squared. This is a squared.
Why did they do it like that?
And we have to do b over a, so it would be 3 over 2.
So y is considered b?
The number underneath y is the b. So it's 3 over 2. And then the x didn't have anything in parentheses, so it would just be x. It wouldn't be x squared, it would just be the x. Because normally it's whatever the parentheses are. And these parentheses would have been like x plus 0 or x minus 0, which is why they didn't have parentheses there. So we'll just say x. Okay, so what do we do next? Yeah, in this one, because the x parentheses don't have anything, we don't really need to make two equations. But for the sake of being consistent, I'm still going to do it. So I'm writing the two possibilities. And what do I need to do on each of them? Just add the 2 over. So y equals positive 3/2 x plus 2. Y equals negative 3/2 x plus 2. And if I look back at my picture, I can see that both of these have a y-intercept of positive 2, which is what I expected. And then one of them goes up 3 to the right 2, and the other one goes down 3 to the right 2. So that's what I expected. They have the right slope, they have the right y-intercept. Okay. So we are going to practice this. Ready? Break. So we're going to find the parabola. Not parabola, hyperbola with a center of -3, -2. A focus of -3, -2 plus 2 square root 74. And a vertex at -3, -12. So center at -3, -2. The focus, one of them is at -3, -2 plus 2 square root 74. And then the vertex is at -3, -12. So we know the center, which is nice because that's half the battle, right? The vertex is going to help us figure out if this hyperbola goes up and down or left and right. So if we picture drawing the center, that would be left 3 down 2. The vertex is left 3 down 12, so that means that one of the hyperbola pieces looks like that. So what does that mean for our equation?
Up and down.
It's up and down, which means that the y comes first. Okay. So we're going to have y something squared minus x something squared equals 1. Again, we know that because the vertex went down from the center. That's why it's a y first. Okay. Based on the center, what should be in the parentheses with my y? Plus 2.
Oh, plus 2.
Plus 2, yep. And then the x should be
3.
plus 3. Okay. How far is the vertex from the center?
10.
10.
What is 100?
So 100. Something's 100. Which one?
The one in the Y.
The one underneath the y, because it went up and down 10. So this one would be 100. Okay, so based off of this information right here, because we have a -2 and a -12, that tells us that the b value is 10. And if b is 10, then b squared is 100. Okay. The focus gives us the c value. Right? So here's the center, -3, -2, plus the c value. So we know that the c value is 2 square root 74. So what equation do we know of that has the b and the c involved? A squared plus b squared equals c squared. So we're going to say a squared plus 100 equals 2 square root 74 squared. I got the c by looking at the focus. So anytime, if you guys have noticed that, anytime they give you a focus, they're giving you the c value for this problem or the p value for the parabola problem. Okay, so that the focus is always important because it always gives you something. So I'm just going to double check and see what 2 square root 74 is after I square it. That's 296. Okay, so a squared plus 100 equals 296. So a squared is 196. I like how you say it. All right. And we're done. Okay, we're going to do one more like this, just with different clues.
Can we do one from the sheet?
I want it to be in your notes, so no, we're not going to do it from the sheet, but then if you want to do one from the sheet, we can. All right, find the hyperbola with the center, not center, with vertices. -1, 5, and -1, -13. And the asymptotes are y equals 9/5 x minus 11/5 and y equals -9/5 x minus 29/5. Yeah. And I could try doing, you know, the fancy and sign? Like, those are hard to draw. You don't think they're hard to draw?
Yeah, you gotta get used to it.
I like my little A. All right. I know I was offended. I was like, whoa, fine. You got to get better at this one. All right. So we have two vertices. Are the vertices up and down from each other or left and right from each other?
Up and down.
They're up and down from each other, right? Because the x value is the same, the y value is what's different. Okay, so if the vertices are up and down from each other, what does that tell us about our equation?
Y first.
The y comes first. Okay, so y squared. Okay. If we have the two vertices, can we find the center? Yes. How do we do that? Find the midpoint. We want to find the middle. Okay. So I'm going to say -1 plus -1 divided by 2. And 5 plus -13 divided by 2. So the center is -1, -4. So in the first set of parentheses, plus 4, right, because it's the y coordinate. And the second parentheses, plus 1. Okay. So now we have to figure out the a and the b value. So we know the a squared and the b
The
squared.
B is 64.
The b is 64. How do you know the b is 64?
Because it's 8.
You're close. It's not 8. You're close.
9.
It's 9. Okay. So we know if we look at the center, the negative 1 stays the same. So we're not going to find the number underneath x. But the number underneath y, we can check here. From negative 4 to 5, or from negative 4 to negative 13, is a length of 9. So from the center, you went up 9 and down 9, which means that the number underneath y should be 1. And notice we haven't used the asymptotes yet at all. We haven't used those. So the nice trick about the asymptotes, if you guys remember, is that the slope of the asymptotes comes from b divided by a. Right? So b divided by a is 9 over 5. That means that the b value was 9, which squared is 81.
25.
And the a value is 5, which squared is 25.
Oh.
And we're done.
Yeah.
Now, the only thing you have to watch out for is it is possible that the fraction had been simplified, right? If it was 2 over 4, it could be simplified to 1/2. So just be careful, because it is possible where they give you a problem where that fraction was simplified. So maybe this, we know that 9 squared is 81, but maybe they had like a 3 over something there because it simplified somehow. Okay, so just be careful to watch out for that. But yes, when they give you the asymptotes, basically what you can take away from that is you have the b value over the a value. Okay, and that's the nice little trick. Alrighty, that's all I had to show you. So we're doing those 2 sets of things. We're being able to graph hyperbolas and look for different characteristics of them, and then we should be able to look at the different clues and write the equation.